And welcome back to Channel 3 News. I'm Steve Jones. Today we have a special story before our scheduled news from Eielson Air Force Base in Alaska. According to the EPA, pollution known as PCBs have been impacting the sediment and fish. Let's go now to Dave in the field for analysis in Alaska.
Thank you, Steve. This site that I'm currently at has both closed and active on-line landfills, shallow trenches where weather tank sludge was buried, a drum storage area, and other disposal and spill areas. This contamination from the PCBs has impacted the sediment and fish in this surrounding environment here. A portion of the PCB contaminated sediment has been excavated, and the PCB contamination in fish tissue and sediment continue to be monitored. To help stop the spread of contamination, fishing restrictions are in place for Garrison Slough, and physical fish gates restrict the passage of fish into and out of the contaminated area.
Exactly how do these PCBs impact the fish, Dave, and can this lead to contamination in humans?
Excellent question, Steve. The fish are contaminated and collect PCBs in their body through bioaccumulation, which is when something that cannot be broken down is ingested, and as more is ingested, it accumulates in the body. Then, when that animal is ingested by a bigger animal, the PCBs are passed on. You can draw a clear connection between PCBs in fish and PCBs in humans because of bioaccumulation, and this is why it is emphasized that fish near contaminated areas are contained and not ingested. Back to you, Steve.
Thank you, Dave, for that on-site analysis. Now let's take a look at the chemistry side of these PCBs. Joining us now is Chief Scientist on the Eielson Air Force Base, Mark Montgomery. Thanks for joining us, Mark. Thank you for having me. Eielson Air Force Base has been dealing with these PCBs for nearly 50 years now. Why is this such a long-lasting problem? This is a long-lasting problem because of the chemical properties that made them so popular. They are chemically stable, non-flammable, with high boiling points, and electrical insulating properties. These properties are what made these PCBs break down so slowly in the environment. Most PCBs settle at the bottom of river and lake beds and bioaccumulate into fish and humans. And why were these PCBs created? The term PCBs is actually an acronym, similar to the acronym FBI. It stands for polychlorinated biphenyls. They were first produced in the 1920s because they were very valuable in electrical equipment, buildings, and machinery. They were used because of their fire resistance, chemical stability, and electrical insulating properties. They were also used as plasticizers in paints, plastics, and rubber products, along with many other industrial applications. Within only a few years, PCBs had spread all over the world. After scientists had discovered that PCBs were toxic to humans and animals alike, they were banned in 1979 by the international community. Although they were banned, they can still be made unintentionally when high heat and chlorine are used in some manufacturing processes today. The chemical formula of PCBs is C12H10-N ClN, C being carbon, H being hydrogen, and Cl being chlorine. I've drawn up this little diagram here to show the PCB molecular structure. Here we have chlorine and another chlorine bonded together, and these are PCB. This is a PCB. Now, theoretically, 209 different congeners are possible, but only about 130 of these have been identified in commercial products. As stated before, these congeners have very low water solubilities. Pure individual PCB congeners are colorless and often crystalline. Commercial PCB mixtures are clear to yellow oils or resins, and they do not crystallize, even at low temperatures. Thank you, Mark. We'll be right back with our scheduled news, ladies and gentlemen, right after this short break.